Go has no try-catch, no exceptions, no throws declaration. Instead, errors are plain values returned from functions like any other value, checked explicitly at the call site. This makes error paths visible in the source code, which is exactly what you want when debugging a production incident at 3 a.m. This episode goes full error model, creating errors, wrapping them with context, inspecting error chains, custom error types, and the patterns that make error handling readable without being noisy. In Go, error is just an interface. Any type that implements error, string is an error. The standard library provides two functions for creating simple errors. Errors. New creates a simple static error. FMT. Errorf lets you format a message with values. Both return a value satisfying the error interface. Functions signal failure by returning error as the last return value. By convention, nil means success. The caller checks immediately. This is Go's answer to exceptions. There's no hidden control flow. Every function that can fail says so in its signature, and every caller must acknowledge the error. You can discard it with, but that's a deliberate choice, not an accident. Linters actively warn about discarded errors. Real applications call many functions. By the time an error bubbles to the top of the call stack, you've lost track of where it came from. Error wrapping fixes this. Go 1.13 added the %w verb to FMT. Errorf. Each layer wraps the error with context, building a chain. Reading left to right tells you exactly what the program was trying to do at each level. This is immensely useful in logs. To inspect a wrapped error chain, use errors.is and errors.as. Errors.is checks whether a specific error appears anywhere in the chain. Errors.as extracts a specific error type from anywhere in the chain. Errors.as walks the chain and assigns the first matching error to the pointer you provide. You get access to the concrete types fields, information you'd lose if you were just checking strings. Never use string comparison to check errors. Error equals not found. The message might change. Use errors.is with sentinel values instead. A sentinel error is a package-level var that names a specific failure condition. The naming convention is error prefix, exported so callers can check for them. You define them once. The rest of the codebase wraps and checks them. The caller doesn't need to know the exact message, just checks for the sentinel. Standard library sentinels you'll encounter constantly. io.eof, os.errNotExist, sql.errNoRows, context.deadlineExceeded, context, cancelled. All work with errors.is through wrapping. Sometimes you need to attach structured data to an error, not just a message. Define a struct and implement error, string, return it like any other error, extract it with errors.as to access the fields. A useful pattern. Make your custom error implement unwrap, so it participates correctly in the error chain. With unwrap, callers can use errors.is and errors.as to inspect the cause even through your custom wrapper. Go 1.20 added errors. Join for collecting multiple errors. Useful for form validation where you want to return all failures at once. Errors. Join returns nil when given no errors. Convenient because you don't need to check length first. The joined error implements unwrap. Error. So both errors.is and errors.as traverse all branches of the joined error. The early return pattern keeps error handling flat. Instead of nesting your happy path in else blocks, return early on error. Each step is a guard clause. Fail fast, return immediately, let the caller handle it. No nesting, no else branches. The happy path reads straight down. Add context at every layer. A rule. Wrap errors with the name of the function that failed. The resulting error message reads like a call stack. Start server. Connect DB. Dial TCP. Connection refused tells you exactly where to look. Don't double log. A common mistake is logging an error and returning it, then the caller logs it too. Log once at the point where you handle it, usually near the top. Intermediate functions should wrap and return, not log and return. Defer for cleanup. When you open a resource, defer its close immediately. If close can return a meaningful error and you care about it, use a named return. The deferred function can write to the named error return. The close error surfaces only if no write error occurred first. Panic is not for errors. It's for programming mistakes. Index out of bounds, nil pointer dereference, impossible states. Never use panic for expected failures like file not found or invalid input. Recover can catch panics inside a deferred function. The standard use case is recovering at the top of an HTTP handler so a panic in one request doesn't crash the whole server. This is the extent to which you should use panic and recover. For everything else, return error. Error is an interface with one method. Return it as the last value. Check it immediately. Never silently discard it. Wrap with FMT, errorf, context, %w, error, to build diagnostic chains. Use errors.is to check for sentinel errors through wrapping. Use errors.as to extract custom error types through wrapping. Sentinel errors are package-level vars with error prefix. Custom error types implement error, string, and optionally unwrap. Errors. Join collects multiple errors into one, go 1.20. The result implements unwrap. Error so both errors.is and errors.as work through it. Early return keeps code flat. Wrap at every layer. Log once at the top. Panic is for programming mistakes, not business errors. Episode 13 covers concurrency, coroutines, channels, select, and Go's approach to writing safe concurrent programs. See you there. This course is based on the complete guide to Go programming, available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 13.